Now this is a very interesting problem. Design a Turing machine to accept a language containing palindrome strings over sigma is equal to a comma b. So we have a language which contain palindrome strings. What are palindrome strings? So if you're going to read from front and back, it should be one and the same. Okay, like this. These are examples of palindrome strings. So you know what is a palindrome string. All these strings are formed with only A and B. So if there is a A in front, there should be a B at the last. If there is a B in second place, there should be a B at last but one position. That is what is the logic we are going to follow. If you have a A, then you are going to make a traversal to the extreme right till the blank and then come one step forward to confirm that this is the last symbol. Now that we will be changing. That will be checking whether it is a A. Now if you are going to have a B, we will likewise we'll be checking. First we'll be checking A now. So if both there is A, then there should be a at last. If there is a B, then there should be a B at last. So if if another B is there, then there should be a B like this. So this is what is the logic we are going to use. First symbol we are going to read, either it is a, then we'll try and find out, move towards the extreme right, and we'll try to find out one A, compulsorily one A, and we'll be converting both the A's to blank. Then we'll move to the extreme left till the blank and then move one step right, and whatever may be, if it is B, then we'll be trying to find another B by traversing to the extreme right and one step forward. Okay, so this is what is the logic we are going to follow. Now let me draw the transition table. So initially you are in one state Q0. When the string starts with A, you replace that with blank and move towards right. Okay, in between there can be any number of A's and B's. That depends upon the length of the string. So whatever may be, we are least bothered. We have to go to the extreme right. Okay. Till then, you convert all A's to A, move towards right, B to B, move towards right. Now, how will you identify the extreme right? When a blank comes, we are confirmed that we have reached the end of the string. Replace that with blank, move towards the left hand side. So left hand side, if here there is a, definitely there should be a here. Only then we call it as a palindrome string. Then replace that with blank and move towards left. We have identified, suppose we are going to consider this A string. For this A, we have converted to B and you have moved to the extreme right till blank and moved one step forward in the left, and you have converted this A to B now. Now again you have to move till this position to complete the process, right? So in between there can be A, move towards left, there can be B, move towards the left. When a blank comes, we have reached where we have started. So in that case, we have to move towards the right hand side to fetch the next letter. Now next letter, if it is going to be B, then we need to identify one B. So the same has to be repeated. Move towards right, B, replace that with B, move towards right. And if a blank comes, you replace that with blank, move towards left hand side. So we have reached the final state. This is Q2, this is Q3, this is Q4, and this is Q5. We have reached the end of the string now. This blank we have arrived. This we have converted to blank. And this blank we have arrived at. This blank, we'll move one step left. And there should be a blank B for sure. That we are going to convert to blank and move towards the left hand side. So once we are moving towards the left hand side, in between there can be A's or B's. In that case, we'll move in the left hand side. And when blank comes, you replace that with blank, move towards right. So in this case, from here, instead of A and B, if blank is coming, what does it mean? So we have reached or traversed through the entire string. So we can replace that with blank and move towards the final state. What is the final state? Q6. Q6 is the final state. Now this works well for palindrome strings of even length, but this won't work for palindrome strings of odd length. Say for example, let me take this one, A, B, A. Now this is also a palindrome string, but this is of odd length. Okay. Now what will happen according to this transition table? So initially we are in Q0, you will replace this blank, and then in Q1 you will be this B, you replace this with B, this A, you replace that with A, and move towards the right hand side. Blank comes, you replace that with blank, okay, and move towards the left hand side. B comes, replace that here, replace that with B, move towards left hand side. Now blank comes, you replace that with blank, move towards the right hand side. Now this B is coming, replace that with B, come here. Next blank is coming, you replace that with blank and move towards the left hand side. See here, in odd length palindrome, you are in state Q5 if your in between symbol is B, and if your in between symbol is going to be A, then you will be in Q2 state. You will be in Q2 state. So from here, if you are able to give a transition to final state for blank, replace with blank and halt, that will bring the answer for both odd length and even length palindrome. Okay. So if you're going to have in between A, you will be striking somewhere here. After B, converting this B to B and moving towards left, there is a B. In that case also, it is a odd length palindrome. For odd length palindrome, this is what the scenario that will happen. So if you have a transition path from this state to the final state, then that also will be accepted. Odd length palindrome will also be accepted. So this is the corresponding transition diagram for language that contain palindrome strings over sigma is equal to A comma B the whole star. So this contain palindrome strings over sigma is equal to A comma B. Okay. I hope this video is clear for you. Thank you.